Hey students, so this is the notes for 6-3, which is on rectangles. Rectangles are the only shape that we're covering today. The next time we do notes, we will cover rhombus and square together. But in your vocab folder on page 23, let's go ahead and put some color on this to show that we have actually covered the definition of rectangle. And be expecting a vocab test pretty soon over any and every vocab word that we have covered so far. So a rectangle is a parallelogram with 4 right angles. Actually, the definition really says you only have to have one right angle. So if you ever see that it has 4 right angles or it has 1 right angle, it can be classified as a rectangle with just 1 right angle. This is the reason why. It says it's a parallelogram. The properties of a parallelogram tell us that these are parallel. So if this is 90, this has to be 90 because they are consecutive angles and they're supplementary. These angles are equal to each other. So if this one's 90, this one has to be 90. These are consecutive, they add to 180. These are consecutive, they add to 180. So technically, you only have to have one right angle for it to be classified as a rectangle. Keep that in mind for later. Okay, let's go through the notes. There are no proofs in the notes, but there are 2 proofs in the assignment that goes with these notes. Okay, so that'll be just a surprise to see if you can figure out how to work those out. Okay, so let's do a warm-up, and the warm-up question says, the measures of 2 consecutive angles of a parallelogram are in the ratio of 5:4. We haven't really covered extended ratios, but I kind of helped you on the last worksheet by giving you what the angles were. But let me just give you a picture of this. If this is a parallelogram, but you really don't need a picture because it says that they're consecutive angles, but that means one of the angles is represented by 4x and the other angle is represented by 5x. So 4x plus 5x, and then you know that consecutive angles in a parallelogram are going to add to 180. Okay, so 9x equals 180. X would equal 20. The question says, what is the measure of an obtuse angle of the parallelogram? Well, I figured 5 is bigger than 4, so I put 5 as the obtuse angle. 5 times 20 would be 100, and that is the answer. 4 times 20 would be 80, so that proves to you that 100 plus 80 is 180. That's the acute one, that's the obtuse one. The ACT loves questions like this, so just keep that in mind. Okay, so here's our definition again. A rectangle is a parallelogram with 1 right angle, and I told you why the others are automatically right. Okay, so properties of a rectangle. A rectangle has all the properties of a parallelogram. Remember, that's 5 things you have to know about a rectangle right off the bat. That means opposite sides are parallel. If they're parallel, we have consecutive interior angles. If the diagonals are drawn, then we have alternate interior angles. Okay, so you got to remember that. Opposite sides are congruent. You kind of think that's the definition of a rectangle, but it's not. Having the sides congruent doesn't make it a rectangle because a parallelogram has opposite sides congruent. That's what makes it a parallelogram. Okay, so 2 things about the sides, 2 things about the angles. These angles add to 180. These angles are equal to each other. 90 equals 90, 90 equals 90, so that does fit. 2 about the sides, 2 about the angles, 1 about the diagonals. The diagonals will bisect each other. I'm going to show you that down here, but there's also a new property about the diagonals. Okay, they do bisect each other, but there's something special about it. So here's the new properties. The new properties are: a rectangle contains 4 right angles and is therefore equiangular. Is it equilateral? No, it's not equilateral, but it is equiangular. So remember, a figure doesn't have to be, if it's equiangular, it doesn't have to be equilateral. And then the diagonals of a rectangle are congruent. Okay, so we know about the 4 angles. It's kind of the definition of a rectangle. 4 right angles, or we could say 1. The diagonals of a rectangle are congruent. So this is what I was going to show you. Hold my place. Okay. When you have a shape, okay, when you have a shape, and like a parallelogram is leaning like this, the diagonals are not congruent because you have your parallelogram. Imagine a parallelogram. The diagonal this way is much longer than the diagonal this way. Remember, I told you in the video, if you would just take your fingers and measure, you would see that in a parallelogram, one of the diagonals is much longer than the other one. Okay, well, if you use your fingers and measure this way, this diagonal is going to be completely equal to that diagonal, because what happens is, imagine this is a parallelogram. When you straighten up to have 90-degree angles, you have made this diagonal shorter and you've made this diagonal longer. So it goes from this, as you straighten it back up, the diagonals are now equal to each other. So any shape that has right angles in the corner, hint, hint, okay, is going to have congruent diagonals. That would be a rectangle and a square, by the way. So when you lean it over, this diagonal stretches longer, this one goes shorter. Okay, so keep that in mind. For the diagonals to show they are bisected, so we can do this, but they're congruent. So instead of putting a double mark here, I'm going to put a single mark here. So if this little segment is 5, this segment is 5, the whole thing, GJ, would be 10, H, whatever letters they are, would be 5, this little segment would be 5, and the whole thing would be 10 equals 10. So they are equal to each other. Okay, let's talk about this. This is a little hidden secret in the rectangle pictures that nobody talks about, that you're not expected to learn, you're expected to know it automatically. This picture, look at the markings, makes 4 isosceles triangles, and all the properties of an isosceles triangle apply. So if I have these two sides equal, that means these two little angles are going to be equal. This is actually a reflection. It folds over this way, and so everything that's happening over here is also happening over here. These two angles are equal. Actually, the ones that I'm pointing at are all the same degree. I know this is a really small picture, but if you wanted to draw a rectangle bigger, I could show you probably better. Okay, so in this rectangle, I'm going to put a dot here, 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 and here. All 4 of those angles would be the same measure, okay? And then these two triangles, because remember, we've got isosceles triangles. These two triangles are going to be exactly the same. It is a reflection this way. And these angles that I'm going to put 2 little dots in would all have the same measure as well. What do these two angles have to add up to? 90. Okay, so they're going to add up to 90 in all 4 corners. And then remember, you have linear pairs and you have vertical angles. Okay, in this picture, I only have to give you one of the angle measures and you can find everything else. Okay, which is what you're going to be doing in your work. All right, so this problem is off of knowing that the diagonals of a rectangle are congruent. If WY is 19, then what is ZX? Also 19. If WY is 19, then what is WT? Go ahead and answer that question. What would WT be equal to? Hopefully you said 9.5, because if this is 19, then these little pieces are equal. T is the midpoint of WY. Okay, and if TX is 4.5, then what is WY? Go ahead and answer that question. And if you said 9, you have that right. So if TX is 4.5, then that means this is 4.5. The whole thing here is 9, and the whole thing here is 9. Very easy. Okay. Rectangle GALS. One of the first tips I tell students on the ACT is if it says rectangle GALS, you need to draw a rectangle GALS, because what's going to happen, you immediately draw it, because what's going to happen is you're going to read all the problem, then you're going to draw it, and you're going to read it again, and you've missed some time. So as soon as it says triangle ABC, you jot down triangle ABC, rectangle GALS, and you draw it. Diagonal GL and diagonal AS. And of course, this one you could have done without drawing a picture, but I just wanted to make that point. We know that GL is going to equal AS, which is 5A minus 18. Go ahead and work that out for me and find out what A is. Okay, you should have got A is 12. Very simple questions. Your worksheet will have some simple questions like that, just making sure you know the basic properties. Okay, the angles of a rectangle, the corner angles are all 90 degrees, and I told you if I gave you one angle, we can find all of them. I'm going to show you how fast this is. All right, so I know this is 55. Without even thinking, I need to put a 55 here, a 55 here, and a 55 here, because these are the same triangles and they're isosceles. So 55 plus 55 is 110. So this angle here would complete it to 180. So 180 minus 110 is 70. So that means angle 3 is 70. Okay. This angle here is 90. What would that be? 35. So this angle is 35. And then without thinking, I know all of these others are 35. Okay, and then I could do a linear pair, or I could use the triangle. It doesn't matter. And so 70, this is not drawn to scale, it looks like. Definitely not drawn to scale. But this would be 110, and this would be 110. Okay, picture's not drawn to scale. They should have actually said angle 2 was 55, and that would have fit better. But if I give you one angle in this picture, you can find all of them, and you should be able to do it very quickly. Okay, so quadrilateral ABCD is a rectangle. Angle BDC is right here. And then angle ADB is right here. What do you know about those two angles? They add to 90. The question says find the measure of angle BDC, so we'll be substituting in to this one. Okay, so would you please go ahead and complete that problem? Your final answer will be after you substitute in. All right, so we added the two angles to 90. Can I go ahead and tell you that this is one of the most often missed questions with a rectangle, because students don't see the 90 and they do not put these two angles equal to each other. These angles are not going to be equal to each other unless this is a square, okay? What happens is if you push this closer together to get a square, this segment goes up a little bit and it makes these two angles equal. So these are always, this triangle is not the same as this triangle. Okay, this triangle and this triangle are completely different. This angle is not the same as that angle. So don't fall into that trap. But anyways, I added them to 90. I got x equals 6. And then my final answer is 43 degrees. Rectangles are not hard. Okay, and let's look at some segments. So AE is 5. And when I put this in the picture, look how I wrote it. I know I'm on that segment, so I don't have to do any markings. I'm put it on the segment. BC is 6. DC is 8. And we're going to find what they have over here. So first of all, in this picture, I know if this is 5, this is 5, this is 5, and this is 5. I know this is 8 and this is 6. It's got to be one of those answers there. So it looks like AC is going to be 10. BD is going to be 10, which makes sense. AD is 6, and AB is 8. See how quick that was? You should be able to fly right through these problems, especially the ones that don't have any algebra. Okay, number 2, let's label our picture. BD is 3x minus 7. Now, this is a problem, okay? So BD is 3x minus 7, and CA is x plus 5. So the problem with that is it's kind of hard to write it in the picture. This is the only time I really don't label my picture. I've got it darkened, so I know I'm looking at the diagonals completely. Okay, so be careful with that. Oh, by the way, if they ever just give you half of a diagonal, you would say 2 times this equals this. Just saying, it's going to show up. If they gave you only AE, you would say 2 times whatever they gave you here to equal this one. Okay, so go ahead and work out that problem, find those answers. I'll ask you one question about that problem. There's your answers, and I asked you if CA what that equaled, and it does equal 11. So if this whole segment is 11, then these are 5.5 each. Very good. Okay. Also, don't forget that we have a rectangle is a parallelogram, and so you do have alternate interior angles. Okay, don't forget that if just one diagonal is drawn, you have alternate interior angles. So I know that angle marked 60 is the same as angle 1. So angle 1 is 60. It also helps to write it in the picture. I know I have a right angle, so this has to be 30, which means angle 2 has to be 30. So 4 and 2 are 30. And angle 5 is 90, and angle 3 is 90. Okay? All right, go ahead and work out this problem. We have to start with the 50. They gave us an easy number. I'm going to ask you one question about this problem. Go ahead and find all those answers. Once again, the person who made this problem did not fact check themselves, and it's not drawn to scale. Okay, this 50-degree angle actually should have been there, and it would have made more sense. Everything would have matched up. But anyways, if you go by what they gave us, it's not drawn to scale. We get well, you can look at the picture and you can see. I did forget to put the 100 here. There we go. And so you can see the angles inside the triangle add to 180. This is isosceles, this is isosceles, 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 and that's how I get those other numbers. Super easy. Okay, go ahead and find the answer to letter D, problem D. All right, there's my work, there's my answer. All right, let's talk about this challenge problem. In a rectangle, the length is twice the width. So that means, you guys know length is the longer one, width is the shorter one. Okay, the perimeter is 48, so that means all of these are going to add to 48. Find the area of the rectangle. Area of a rectangle is length times width. Okay, so the length is twice the width. So if I let x be the width, then the length is twice that. And you have a formula. You can say 2x plus 2x plus x equals 48. That's the perimeter. So we've got to get these pieces here. By the way, no, you didn't have to write all this out. You can go ahead and say 2, 4, 6. So x equals 8. So that means this side is 8 and this side is 16. And then the area is length times width. And that gives us 128, and we don't know what the units are. So technically we're supposed to put 128 units squared, whatever the units are. All right, the ACT loves questions like this. Loves it. All right, this just goes over all the properties of the rectangle. Remember, these are the fabulous 5 that go with the parallelogram. 2 about the sides, 2 about the angles, 1 about the diagonals. These are the new properties where a rectangle, this is the actual definition. Rectangle has 4 right angles, and then remember that the diagonals are congruent. Okay, I do have one more thing I want to show you, is that on the worksheet, you're going to be using the Pythagorean theorem. Remember, whoops, A squared plus B squared equals C squared. You're probably expected to already know that for my class. And so I'm not going to work out this whole problem, but I want to show you. If I was to ask you to find SQ, and I'm given these pieces, I would say 10 squared plus 24 squared equals C squared, because this is my right angle. And that would be 100, don't know 24 squared off the top of my head, 576. I actually did know that. So 676. And then remember, to get C, we take the square root. And the square root of 676. And you can give me, if it's a decimal answer on your worksheet, you can give me just one decimal, but this one comes out to a whole number. So C would be 26, so SQ would be 26. And then the other pieces would fall into place. This would be 13, this would be 13, 13, 13, 26. Okay, so for this question here, they gave us that this was 15, so that means the whole thing is 30. I typically don't write it like that because now you think this is 30. That's why I hate writing this in there like that. But anyways, I'm not doing the whole problem. The whole segment AC is 30. We've got DC is 27, and I'm going to find AD. There's my right triangle. Okay, so can you go ahead? I'm going to set it up for you. Go ahead and work out that Pythagorean theorem just to prove to me that you know how to do it. Give me a to the 10th place if you get a decimal. Okay, you should have got 13.1. So you have seen two examples of the Pythagorean theorem. You know that you can't do the Pythagorean theorem with just a piece of the diagonal. You have to have the whole thing. So just keep that in mind. If you get decimal answers, you can round it to the 10th. We're not going to worry about the exit ticket. You are done. Remember, you will have two proofs, and you'll write these statements as an if-then statement. If diagonals are congruent, then it's a rectangle, okay? Or if it's a rectangle, then the diagonals are congruent. If it's a rectangle, 4 angles are right angles, things like that. If they give you the right angles already and you're trying to prove it's a rectangle, if a quadrilateral has 4 right angles, then it is a rectangle, things like that. I think you guys are pretty good at doing that now. But anyways, done with the notes. Thank you for putting all of your effort into the class and doing your work on time. Thanks.